welcome to Sec 106, Detecting Threats in Logs at Cloud Scale. My name is Tim. I'm the product manager responsible for this. And let's get started. So much of Google Cloud is bringing what we do internally to the world. Internally, we use Dory every day to source questions during things like TGIF, which of course happens on Thursday. So today, on Tuesday, you can use Dory to ask me questions at the end of the talk. So diving in, I'm Tim. I'm a product manager here at Google. Past experience at companies like Stripe, where I served half of the accounts at Stripe, and at Shape Security, where I probably ended up installed on all of your phones, protecting all of your banking. So what are we going to talk about today? Today, we get to talk about something we're calling event threat detection. And this is our initial beta launch. We're very excited about it. And ETD is, if you take one thing away from this session, here it is. ETD is a way to detect threats in your logs at cloud scale. ETD is a managed service we're offering that looks at your Stackdriver logs, finds bad stuff in them, and lets you know. You've now got the gist of my talk, and if you want, you can go to a different talk. All right, so what are we going to do? We're going to talk about ETD. We're going to talk about how it integrates, and then I'm going to do a demo. And I will let one person in this room become owner on a project which has a GCP credit card backing it, so you can mine as much cryptocurrency as you want between when I make you editor and when I catch you. So get ready if you want to be owner. So some trends, because what fun would a talk be if I didn't get to talk about a couple of trends real quick. So we think about logs, we think about security, we think about the history of security, and I think about Cliff Stoll's book, Cuckoo's Egg, and how back in the 80s, he found the KGB breaking into Berkeley thanks to log data. A 7-cent discrepancy in the billing logs is what tipped Cliff off. And so we've been doing this for a long time, and what I'm telling you is not rocket science, but it is cool because we're doing it in a way that's managed and new and at much lower cost. So we've built powerful detections. I'm sure everybody here, who here detects threats with logs? Yeah, we all do it. It's cool. But it's expensive. And with the growth in computing systems and the growth of hybrid and multi-cloud worlds, perimeter defense has gotten a lot harder. Log data has exploded in volumes, and putting it all into your legacy SIEM is probably more expensive than you'd like. I talk to users every day who say, oh, I've got all these DNS logs, and if only I could store all of them, I could do detections. And it's too expensive for them. We have end-to-end encryption now on so many of our services, making traditional deep packet inspection, network intrusion detection way harder than they were. And we have heterogeneous systems now presenting really heterogeneous logs. And so if these sound like problems you've seen, they're problems that we've seen internally. And so what we're doing with ETD is dealing with this world, where it's getting more expensive to fail, where compliance and regulation are more expensive than ever. And despite all that we're spending, our losses remain stubbornly high. And we wouldn't be here today if that wasn't the case. So it's really exciting to see everybody here validating what I said, because nothing's better than having what you say validated. So ETD aims to address all of this in this context. So you may have seen this slide before at this show. This is the Google Infrastructure Security Defense in Depth story. And what we like to say is, in this world of trouble, we do all of these things for you by default at scale. From our hardware, which is purpose-built for our data centers, from chips to network, ensuring a secure supply chain, to how we do service deployment with signed binaries where everything that goes into production is known from its source, to our storage, how we're automatically encrypted at rest, how we're automatically encrypted at transit, to our identity and access, where I can't log into a system without second factor and real security there. With our secure communication over the internet, where everything is encrypted in transit, and our operational and device security, where 24/7 you, as our users, benefit from our expertise in production. So with that context of bad things happen, the SIEM is expensive, Google's doing some stuff to secure you, we have a world where bad things still happen. Bad guys are still getting in, and even when the IOCs are present, we're not always well equipped to detect them. So what if you, our users, and your users, could take advantage of Google's incredible scale, incredible threat intelligence, and ability to do that all in near real time to protect your environments? So this is where we are with ETD. Event threat detection is what we're announcing. It's inspired, like many things here, by how Google protects itself, and it's built to expect the heterogeneity of the environments that you present us. So ETD today takes in logs from Stackdriver logging, processes them with a combination of our knowledge of cloud and our threat intelligence that we develop by looking at the entire internet every day and using that knowledge to protect ourselves. And we give you findings that are very high quality in Security Command Center. So this is the big takeaway slide. And again, I'm being efficient with your time. Bad stuff on the left, ETD in the middle to process all your logs, findings of very high quality on the right. And so we don't live in a world anymore where we need to put everything into the SEM. We have a world now where we can process our logs in near real time, and we'll see in a minute how fast it is, put the high-quality findings where your analysts can interact with them, and not spend all of that money indexing and storing logs, which you really would have benefited from once and maybe twice if you're doing an investigation. And we can talk about that too. So ETD, Event Threat Detection, streaming logs processor to detect bad things in your log data at Google scale using our threat intelligence. So what does it look like end to end? I think of this as the security logs club journey. First, you produce and centralize. Then you detect. Step 3 is your, what other people would call SOAR, what I'll call enrich, orchestrate, automate. 4, visualize it in one place, a single pane of glass. 5, forensicate, which I insist is a word. And then 6 is remediate. And all of this you can do in GCP more or less out of the box today. And so what does this look like? On the produce and centralize side, the first rule of Security Logs Club is centralize your logs. You're not going to be able to do what you want to do unless you have everything in one place. That's just how it is. You can't correlate, you can't see the connections, you can't get that same visibility unless you're centralizing your logs. So, in GCP, all of our services, by default, and you can't turn it off, produce your cloud audit logs. You can also additionally enable your VPC flow logs, your firewall logs. You can carry logs out of your GCE instances using FluentD. And we're looking at even more log types on the horizon. So in GCP, you have good logging by default that you can make better by turning things on, like VPC flow logs, like your firewall logs, like GCE logs with FluentD. Step 2 is detect. So ETD is here to do that. We will watch your Stackdriver logging stream, and we will give you detections today for these threats. So we look at what we see in GCP. We see plenty of malware. We see plenty of crypto mining. We see lots of phishing. There's IAM abuse. And then these 2 at the bottom here, outgoing DDoS and port scanning. These are common signs that a project or an instance has been popped. It's a common use by a bad guy. Pretty cheap monetization on this, but common sign of lateral movement and common sign of exploitation of an instance. And then finally, SSH brute force, we see as one of the more common ways that instances actually get popped in cloud. And so it's kind of funny that something from so long ago is how we're still getting pwned. So we've built a detection for that because we know it's helpful. And so what are we looking at for these detections? With malware, crypto mining, we're looking at hashes coming out of Linux IMA's module, delivered via auditd and FluentD to Stackdriver. We have an incredible knowledge of hashes that we get from our threat intelligence, threat attribution group inside Google. We have domains and IPs that come from that group and others. And so we're looking at those logs, the VPC flow logs, the firewall logs, to pull out that intelligence. For IAM abuse, we're looking at the cloud audit logs. For outgoing DDoS and port scanning, again, your flow logs. And brute force SSH, again, syslog, delivered via FluentD. So once you've detected, your analysts need some context to evaluate findings. It's no good just to look at a finding that says, hey, there is brute force SSH. Your analyst will say, well, what instance is this? Is this a jump box? Is this something that shouldn't be exposed to the internet in the first place? So we think it's very important to give people this context, and we'll talk about a way to do that with Cloud Functions in a minute. That automation can decorate the functions in Security Command Center, so your analyst doesn't just look at what we know. The analyst can automate what they would do every time they look at that same finding and decorate that context onto the finding. That way they can save time, keep their focus, make better decisions faster. We're going to have an open source community for these cloud functions to pull in context from across GCP, across on-prem systems, and from wherever you want. We're really excited about this. We think that this is not something that people are going to see as secret sauce, but instead is something that they can contribute to making everybody more secure together. Cloud Functions can also export to your ticketing system or SEM of choice. And so the early version of this demo actually sent the findings out to Slack. And I decided not to show you all Slack today because I'm sure we see Slack enough. But there's no reason you can't hook up a Cloud Function and send these things onto Slack or onto Jira, onto ServiceNow, onto wherever you want via that API. And finally, we're going to look at automating response with these cloud functions as well. And so when we get to the demo, you'll see what I mean. And I think it's pretty cool what you can do all within the GCP ecosystem. So having enriched and automated and orchestrated your response, your analyst probably wants to see what's going on. And so with Security Command Center, we'll get more in depth with SCC in a minute. But with SCC, you have a dashboard for your highest priority findings. You have list and detail views where you can analyze your trends over time. You can dig into things, see the correlations. And there's a lot more to come with this product. And Andy Chang, the PM for this, is giving a talk earlier today, which I think is recorded, as well as a encore talk on Thursday because it was nearly as sold out as this. So lots of exciting stuff happening there. Now, Forensicate. We see findings, and it doesn't tell us the whole story. It gives us a point in time. It gives us a single observation. Maybe it gives us a couple of observations. It's not enough for your security team to see that something bad happened. They need to figure out why, how, the extent of the blast radius. And so what we're telling customers to do is take those logs that are in Stackdriver and either store them there or export them to BigQuery. And once your logs are in BigQuery, you can do cool things on your own, using BigQuery ML, building models, understanding what looks normal for your system and what looks like a deviation from that. We think this is really important, and when we look at how Google does this internally, we make a ton of use of Dremel on our security team. And Dremel is what we call BigQuery internally. So we think this is really a fundamental enabler for security teams, and especially if you're moving away from a SEM world and into a cloud world, you'll want to be keeping your logs either in Stackdriver or in BigQuery. Finally, Remediate. So we think about the systems involved in managing security in an organization today, and you've got a lot. I ask users how many things they have. They raise a lot of fingers, sometimes their toes as well. And what we want to do is keep users from having to plug all these different things together, have users get out of the swivel chair mode from one app to another, copy and paste in context, and instead, within the realm of GCP, move your knowledge and information from where detection happens to where visualization happens to where remediation happens. And so IRM, our incident response management system, developed internally to empower our SREs to more efficiently respond to incidents, also is being made available to cloud customers to help you respond to incidents, both operational and security. And so with IRM and with SCC, we have a one-click integration to take a finding out of SCC with all of its rich context, pull it into IRM, and add it to either a new incident, so your analyst can start doing the thing, or into an existing incident as you build that context and that story around how something went wrong, what are all the involved things, what are all of the findings related, and what do we need to do to clean it up. And so this entire end-to-end journey happens within GCP without your analyst copying and pasting, without plugging systems together, without worrying about authorization and access control between the different systems. So what do we actually get in the box today? So if you turn on ETD in the private beta, as I hope everyone here will once we're ready for you, you get a very easy onboarding process. It's turn on the API, and then it's 3 steps. The first is tell us what projects you want us to watch. So this is the sources bit of things. Wow, a lot of photos, that's exciting. So in our world, we think of things in terms of projects, and so you tell us which projects you want us to watch. Either watch all the projects, which is the recommended mode, watch all but a subset you feel privacy conscious about, or watch only a limited subset. And you might do that if you think only these ones matter, or only these ones are valid during a test. So make your choice there. Tell us where you want us to write the findings. By default, we always write to Stackdriver, Security Command Center. And additionally, you can tell us a Stackdriver logging project to write to. And so that Stackdriver logging project is where you'll put your findings so that your automated tools can pick them up so you can do orchestration, automation, and enrichment against those findings. And then finally, you tell us what rules you want us to use. We've got a set of rules today, and it's going to keep growing in the future. And so what we want is for you to turn on all the rules that you're confident in, or all of the rules, and see how it goes. And so as we go through our beta period, we're going to be adding more and more rules, and we have a roadmap. I have some of my engineers in the room, and they don't want me to say how many, but there's a lengthy roadmap, and it grows every day. Every time I talk to a user, you have some cool idea of something you'd like us to detect. So 3 steps to turn it on. Tell us what to watch, tell us where to put the findings, and tell us what rules to use. These are the detections. We've talked about these so far. But getting into the malware one, this is one that we're really excited about. And this is an area we're going to continue growing. So today, it's fairly straightforward. We look at hashes, and we've got good knowledge of what hashes are good and bad. we've got IP addresses, we've got domains. And so for each of these, we're going to be looking at different log types, whether for hashes, it's Linux IMA, or NetFlow, VPC flow logs for domains and IPs. You can imagine, though, that a hash is a hash. And if we have a detector that's looking at hashes in Linux, we could also extend this to look at hashes executed on Windows. And that's where we're going with that. You can imagine, well, Tim, you've got a detector looking at VPC flow logs. What about my on-prem flow logs? What about my on-prem firewall logs? And you're right, at the end of the day, bad IPs and bad domains, they're the same whether they're accessed from GCP or on-prem. And so we're going in that direction as well, expanding this coverage not just to look at your GCP resources, but become log centralization across your entire portfolio. And so crypto mining is the same story, and we see lots of that in GCP. Phishing, this is a good defense for your corp network. And then the others, I'm going to do a demo for the IAM one, which is fun. So with Cloud Security Command Center, that comes with this as part of the experience. This is a way for you to gather and integrate your context at the org level. We've got asset inventory where you can see all of your projects, networks, assets. You can understand the context around your security info. You can act on your security information here. And it's a hub for the entire portfolio of GCP security products and services. And so it's not just ETD. There's Cloud Security Command Center's scanners. There's Cloud Anomaly Detection. There's Security Health Analytics, which is either being announced today or tomorrow, and please don't repeat that if it hasn't been announced yet. And there's a whole host of third-party integrations with SCC as well. And so SCC becomes the central pane of glass where all of your information on threats, on vulnerabilities, and on your underlying assets comes together, where your analysts can act on it in a coordinated, orchestrated, unified place. So what does ETD look like from an architecture standpoint? On the left-hand side, we have the produce stage of logs. Cloud logging is centralized. ETD box is detection. And on the right-hand side, we have two paths. One into Cloud SCC and into IRM for your visualize and remediate. And on the bottom, we have cloud logging off to BigQuery and Cloud Functions to export to your on-prem systems. And so we know that users aren't just on GCP, and we want to meet you where you are. And so we haven't built any walled garden around our findings. We haven't made it deliberately difficult to get them out. We've made it deliberately easy to get them out. In fact, we've gone so far as to build multiple Splunk connectors to get your findings out of GCP and into Splunk, where we know your analysts like to work. It's much easier to hire people who have Splunk experience than SCC experience. So this is what the architecture looks like for the GCP land. Compute logs via FluentD on top, GCP audit logs in the middle, VPC flow logs on the bottom, and there's more to come here in GCP as well. Cloud logging into ETD into your subsequent systems. For on-prem, for custom detection. So lots of users want to say, well, Tim, you've got those detections. I've got this really clever idea of how to detect stuff. And so what do I do? Well, there's a lot of options, but two of them are to put your logs into BigQuery and run a scheduled query, say, every 15 minutes, looking at the last 15 minutes of logs and saying, do I see these indicators? Do I see this pattern? Do I see this correlation? And the other is to do it more similarly to how we do things with a streaming job in Dataflow. And so whether you want to write a streaming detection or a batch window detection, you can do that with the fundamentals that GCP gives you. Stackdriver, nicely enough, integrates really easily with BigQuery, and it's not that hard to integrate with Dataflow either. And so you can take those same findings you generate and put them side by side with our findings, either in Stackdriver logging or in Security Command Center, just like you would any other. And so you have a unified journey here of our detections and your detections working together. In the future, we're going to extend this to make this a little easier to go, give you a little bit more power out of the box when it comes to having your analysts write good rules, test good rules, update and manage the rules. There's a whole lifecycle piece there that we're working on. So I promised a demo, and now I'm going to do a demo. So could we switch to the demo, please? Oh, wait, don't switch to the demo yet. Go back. What I want to show you is the architecture for the demo before we go in, so you know what's going on. We're going to have two demos. The first is going to make somebody owner of a project. And so we're going to look at the audit logs, which are produced automatically, pulled into Stackdriver, into ETD, and then we'll look at the finding in both of the places where they get written. That'll be the first one. The second one, we're actually going to run some malware on an instance, have the VPC flow logs, pick it up, The VPC flow logs go into Stackdriver logging, into ETD, and then we'll see the finding in both Cloud Security Command Center as well as logging. So, first things first, our IAM demo. And now I'm ready to switch over. Let's make this a little bigger so everybody in the back can see it. So, standard GCP Cloud Console. There's no smoke and mirrors. I'm actually just running in production right now, which is kind of fun. Who wants to be added as an editor on this project? What is your email address, sir? Specifically, what's your Gmail address? I need a Gmail address. Yes, please. All right, you're a brave man. We're going to make you editor on this project, and you have as much time as the system gives you to mine as much Bitcoin as possible. You ready? We're going to add you. Yes, update, that's the idea. Okay, so we'll hit refresh and we'll find you here. I'll prove that I added you. There's no smoke and mirrors. There you are as an editor. So congratulations, you now own my project. Have fun. But I don't think you're going to own it for long, because that audit log has been written to Stackdriver, picked up by ETD, and if I hit refresh over here in Security Command Center, we should see a new finding for it. And so I've made this a little small, but you can see here our card on the home page, event threat detection, our findings. We're going to click in, and we'll see right now we have a new finding from 240.45, that was a second ago, and it says persistence. IAM anomalous grant. We'll click into this, and I hope this is big enough that people can see. But you can see the finding type, when we found this, what the source was, and we can scroll down to the properties, and we can see, okay, it's a persistence technique. They're trying to get some persistent access to our organization. We see the user who's been added here. We see the role as editor, and the bozo who added him is me. So as a security admin, you now have a couple of cool things in this finding. One, you have a finding that tells you somebody was added as an owner or an editor who shouldn't have been. So that's pretty powerful. You have exactly who was added. You have exactly what role they got. And you know which person on your team's wrist to go slap for making such a bad choice. And so we see this all the time. It's a common technique to establish persistence in an organization if you own an admin's account. It's a common thing that happens in phishing. It's a common thing that people do if they want to have backdoor access for whatever reason. And so here it is in Security Command Center. We can pop over to Stackdriver and have a look at the log version of it. And you can see here it is at 240. You can scroll down. All of the same information is available here in the JSON object. So if you want to script against this, you can. It goes into PubSub very nicely, exports to on-prem systems very nicely, and it's all there for your automation to pick up and operate against. Now, I wrote some automation as well, and I didn't. Tom did. Tom's here. He wouldn't let me get away with that claim. Tom wrote some automation against this to pick up these findings and actually take away that ownership. And so if we go back to IAM right now, I can hit refresh, and Davis is unfortunately going to be gone. How much Bitcoin did you mine? Not enough, yes, not enough at all. So you can see he's not there anymore. So within seconds, we were able to add him, detect it, and remove him. And just so you know I'm not pulling your leg, here's the execution of that cloud function that did the removal. So that's the first demo. Yeah, all right, cool. It worked, right? So now the next thing, we're gonna connect to an instance here. And this is, a perfectly nice, happy instance. But unfortunately, like many instances, it was running some software that had some vulnerability that some bad person on the internet found and exploited. And so we're going to connect to it. You can see here's a standard cloud SSH thing. And I'll zoom in so you can see what I'm going to do. I'm not actually going to do anything that fancy. I'm just going to run malware.sh. Classic malware right there. And like all good malware, it doesn't tell us it did anything. But it did. It called out to its command and control server, as malwares want to do. And because we have this instance in a network with VPC flow logs turned on, we were able to detect that. So if we tab back over to Security Command Center now, we're going to see a new finding for the malware. And so the malware did its thing, called home, had a TCP connection, got whatever instructions it got. VPC flow logs picked that up. Those ended up in Stackdriver. That ended up in ETD. And the ETD finding will have ended up in Command Center. And so if the demo gods are smiling on me, when I hit this button, we'll see another finding. Look at that. It worked. Very exciting. Here's the malware detection. And so we can scroll down, and you can see again, we're telling you, OK, what's the indicator involved? We were looking at a domain. It's a bad domain, not some like domain-generated domain, just a straight up, we know this domain is bad. It's a technique of malware. I think it's pretty high priority. And then we can scroll down here and look at some properties and see that the malware connected to 3322.org, and it was in this project ID from this subnetwork with this subnetwork name. Now you might say, well, why do I care about the project? And so we want to put in enough context here so that if your analyst sees a finding like this, and the network has some name like malware lab or testing area, they're less concerned than if it says, PCI environment or PHI environment or production. And so just like that, we executed malware and had it show up here. And so I'm not pulling your leg. We'll pull the VPC flow logs. I'm back here in Stackdriver. You can see here's our one at 1444.22. We'll tab over here and look at our detector. 1444.22, 759, 496. So we're looking at sub-second latency on these detections from VPC flow logs getting inserted to Stackdriver and findings ending up back in Stackdriver. And so I'm not going to commit to an SLO of sub-second latency today, but that's what we're running at right now, which I think is pretty cool. So that's the story with the demo. We tab back to the slides, please. So this is what we did. We had an instance get compromised, produced logs, centralized them in Stackdriver, detected with ETD, visualized with SCC, and we've got a world where we could have exported this to our on-prem systems. So looking ahead, what's next with all of this? Where are we going with a product that today just looks at GCP logs? There's a couple of places. We're getting to public beta, which is very exciting. This is going to be a road for us to travel as we get used to the load, get used to reliability, get the detectors to a quality level we feel confident in. I don't want to release detectors to the wild internet that I'm not pretty sure are going to work well. And so all of my private beta users, in for a bit of a ride. We're working on more detectors. So we're looking forward to working with all of you to understand what are the most dangerous things out there, what are the things hardest for you to detect, what are the things that you really wish you didn't have to worry about. Expanding ETD to cover more logs is another journey for us. And so this isn't just GCP logs. It's logs from your on-prem systems. It's logs from your other clouds. It's logs from anywhere. We really want to get to a place where ETD is the thing driving detections for your organization, whether those logs are produced by our services or by somebody else's. We're working to get smarter. And we know that you rely on third-party threat intelligence today from a number of sources. With ETD right now, out of the box, you get our threat intelligence, which we think is pretty good, but we might not know everything. I'll admit that about myself anyway. And so we want to work seamlessly with your third-party vendors, whether that's CrowdStrike, Pan, Checkpoint, McAfee, Symantec. We want to make sure that you can pull in the information you already trust. We want to make this more flexible, so your SOC analysts know your systems better than anybody else. They know which accounts do weird things, which endpoints are good, which IP addresses are bad. And we want to let your SOC analysts shape this system in their image to make sure that it works for them where they are. And finally, we want to get better integrated, like everybody, whether that's putting things in the right places in GCP, whether that's writing these things out to your on-prem systems. So the big takeaway today, ETD looks at logs, finds bad stuff for you automatically. We integrate with Security Command Center and IRM. We're available in a private beta starting today. So there's a sign-up link in a sec where you can go to sign up, and you can sign up. We've got our page at that URL. You can sign up at that URL. If you have questions, you can email me at that email address.